Worlds around us. A cosmic ballet. Planets. These celestial bodies have always fascinated humanity. From the earliest stargazers who looked up in wonder to modern astronomers with their powerful telescopes, planets have been a source of endless curiosity and inspiration. These celestial wanderers have captivated humans for ages. They are not just points of light in the sky, but worlds with their own unique characteristics and mysteries. Each planet has its own story to tell, from the scorching surface of Mercury to the icy plains of Neptune. But what are they, really? Planets are more than just objects in space. They are dynamic systems with complex atmospheres, geological activity, and sometimes even the potential for life. Understanding planets helps us understand the processes that shape our own world. Planets are large, round objects that orbit stars. They come in a variety of sizes and compositions, from rocky terrestrial planets to gas giants. Each type of planet offers unique insights into the formation and evolution of planetary systems. Unlike stars, they don't produce their own light. This fundamental difference means that planets rely on their host stars for illumination. The light we see from planets is actually the reflection of their star's light, which can tell us a lot about the planet's atmosphere and surface. Instead, they reflect the light of their host stars, making them visible to us. This reflected light can vary in color and intensity, providing clues about the planet's composition and weather patterns. For example, the red hue of Mars is due to iron oxide on its surface, while the blue color of Neptune is caused by methane in its atmosphere. The birth and death of planets are fundamental processes in the universe. Planets form from the dust and gas left over after a star is born. Over millions of years, these materials coalesce to form planetesimals, which eventually grow into full-fledged planets. But planets don't last forever. They can be destroyed by collisions, consumed by their stars, or ejected from their systems. Understanding how planets form and how they eventually meet their end gives us clues about our own solar system's history and future. By studying other planetary systems, we can learn about the conditions that led to the formation of Earth and the potential for life elsewhere in the universe. It also helps us comprehend the vastness and complexity of the cosmos. The universe is a vast, interconnected web of stars, planets, and galaxies, each influencing the others in ways we are only beginning to understand. This grand tapestry of celestial bodies is a testament to the beauty and complexity of the cosmos. Imagine a grand cosmic ballet. Stars and planets move in a delicate dance governed by the laws of physics. This dance is not random but follows precise patterns and rhythms, creating a harmonious and ever-changing spectacle. Stars are born, planets form around them, and over eons they evolve and eventually die. This cycle of birth, evolution, and death is a fundamental aspect of the universe. It is through this process that new stars and planets are created, continuing the cosmic dance. This cosmic dance of creation and destruction is happening all the time throughout the universe. Every moment, somewhere in the cosmos, a star is being born, a planet is forming, or a celestial body is meeting its end. This continuous cycle is a reminder of the dynamic and ever-changing nature of the universe. Learning about this cosmic ballet helps us understand our place in the universe. By studying the stars and planets, we gain insights into the forces that shaped our own world and the potential for life beyond Earth. This knowledge not only satisfies our curiosity, but also inspires us to explore and discover more. It reminds us that we are part of something much larger than ourselves. The universe is vast and full of wonders, and our planet is just one small part of this grand cosmic ballet. By looking up at the stars, we are reminded of the beauty and mystery of the cosmos and our own place within it. The story of a planet begins long before the planet itself exists. It starts in giant clouds of gas and dust scattered throughout galaxies. These clouds, called nebulae, are like cosmic nurseries where stars and their planetary systems are born. Within these nebulae, gravity pulls gas and dust together. As more and more material clumps together, the cloud's center gets denser and hotter. Eventually, the core becomes so hot and dense that nuclear fusion begins, igniting a new star. As a star ignites, the remaining gas and dust swirling around it form a flattened disk called a protoplanetary disk. This disk is where planets are born. Think of it as a giant cosmic pizza dough. Within this disk, tiny dust grains collide and stick together, growing larger over time. This process is called accretion. As these clumps grow bigger, their gravity increases, pulling in even more material. Over millions of years, these growing clumps become planetesimals, the building blocks of planets. Planetesimals continue to collide and merge, eventually forming full-fledged planets. Our solar system is just one of billions in the Milky Way galaxy. In recent decades, astronomers have discovered thousands of planets orbiting other stars. These planets are called exoplanets. One fascinating example is the TRAPPIST-1 system. This system has 7 Earth-sized planets orbiting a red dwarf star, and several of these planets might be habitable. Another intriguing system is Kepler 186f, an Earth-sized planet orbiting within the habitable zone of its star. Studying exoplanets allows us to compare different planetary systems and learn about the diversity of worlds that exist beyond our own. Section 5. Planetary evolution, a dance through time. Once a planet forms, its story doesn't end there. Planets continue to evolve over billions of years. Their surfaces can change due to volcanic activity, impacts from asteroids and comets, and even the effects of life. For example, Earth has undergone dramatic transformations over its 4.5 billion-year history. Continents have shifted, oceans have formed and disappeared, and life has evolved from single-celled organisms to complex plants and animals. The evolution of a planet is influenced by many factors, including its size, composition, distance from its star, and the presence of other planets in the system. Section 6. The cosmic clock ticks, stellar evolution and planetary fate. Stars, like all things in the universe, have a lifespan. As stars age, they go through different stages. This stellar evolution can have a profound impact on the planets orbiting them. Our Sun, for example, will eventually run out of fuel in its core. As it does, it will expand into a red giant star, engulfing the inner planets, including Mercury and Venus. Earth's fate is uncertain, but it will likely be uninhabitable. The death of a star can have both destructive and creative consequences for its planetary system. Section 7. Planetary demise. When worlds collide. In the early stages of a planetary system's formation, collisions between planetesimals and protoplanets are common. These collisions can be incredibly violent, shattering planets into pieces or even merging them together. Scientists believe that a Mars-sized object collided with Earth early in its history, creating the debris that eventually formed our moon. This event highlights the dramatic role collisions play in shaping planetary systems. While collisions are less frequent in mature planetary systems, they can still occur. Asteroids and comets can collide with planets, causing significant damage or even leading to mass extinction events. Section 8. Death by star, engulfment and evaporation. As stars age and evolve, they can pose a direct threat to their planets. The life cycle of a star is a fascinating journey, beginning with the birth of a star from a cloud of gas and dust, and ending in a dramatic death that can have catastrophic consequences for any nearby celestial bodies. When a star like our Sun runs out of hydrogen fuel, it expands into a red giant. This phase is marked by a significant increase in the star's size and luminosity, causing it to swell to many times its original diameter. The outer layers of the star become cooler and take on a reddish hue, giving the red giant its name. This expansion can engulf nearby planets, vaporizing them completely. Planets that were once in the habitable zone may find themselves swallowed by the star's outer layers, their surfaces melting and their atmospheres boiling away in the intense heat. Even planets that aren't engulfed can experience a fiery demise. The intense radiation and stellar winds from the red giant can strip away a planet's atmosphere, leaving it exposed to the harsh environment of space. Without an atmosphere to protect it, the planet's surface can be scorched and its water evaporated. As the red giant star sheds its outer layers, it releases intense heat and radiation that can strip away a planet's atmosphere and vaporize its surface, leaving behind a barren core. This process can take thousands to millions of years, but the end result is a lifeless, rocky remnant that bears little resemblance to its former self. This process of planetary engulfment and evaporation is a reminder of the immense power of stars and the eventual fate that awaits many planets. It highlights the dynamic and often violent nature of the universe, where even the most stable and life-supporting environments can be transformed into desolate wastelands by the forces of stellar evolution. Understanding these processes not only gives us insight into the future of our own solar system, but also into the life cycles of planets and stars throughout the cosmos. Section 9. Cosmic recycling, from death to new beginnings. While the destruction of planets may seem like an ending, it's actually part of a larger cycle of cosmic recycling. The universe operates on a grand scale, where the death of one celestial body can lead to the birth of another. This process is a testament to the incredible balance and harmony that governs the cosmos. When stars die, they expel vast amounts of gas and dust back into space. These supernova explosions are not just spectacular events. They are also crucial for the creation of new celestial bodies. The remnants of these explosions spread out across the universe, seeding the cosmos with the building blocks of new stars and planets. This material can eventually become part of new nebulae, the birthplaces of future generations of stars and planets. Nebulae are often referred to as stellar nurseries because they are the regions where new stars are born. The gas and dust within these nebulae coalesce under the force of gravity, eventually igniting nuclear fusion and giving birth to new stars. The atoms that make up our bodies, our planet, and everything we see around us were once forged in the cores of stars. This means that we are all made of star stuff, a poetic reminder of our connection to the universe. The iron in our blood, the calcium in our bones, and the oxygen we breathe all originated in the hearts of ancient stars. The cycle of stellar birth, death, and rebirth ensures that the universe is constantly evolving and creating new worlds. This ongoing process of transformation is what makes the universe so dynamic and ever-changing. Each generation of stars contributes to the next, perpetuating the cycle of life and death on a cosmic scale. Understanding this cycle helps us appreciate the interconnectedness of everything in the cosmos and the profound implications of planetary birth and death. It reminds us that we are part of a much larger story, one that spans billions of years and countless light years. By studying the life cycles of stars and planets, we gain insight into the very nature of existence and our place in the universe.